right, this is your recording for lesson 31, the second day, where we're going to be mostly talking about work problems. Before we do that, the first thing that we did in class today was to review what we did in the first half of lesson 31, which was to solve rational equations. So we're just going to work through one of those examples. We're going to look at number 6, which is on page 465. So in the margin of your book there, go ahead and turn there, 465. So you need to work this out, or if you, for some reason, don't have your book, have a piece of paper out. All right, so this is what we went through on Friday when we went through the first half of lesson 31. So very similar to what we've been doing in lessons 29.1 and 29.2, in that now we are factoring, we're simplifying, we're adding, subtracting rational expressions. So the steps that we went through for these remind you that there were two types. Type 1 was where there's just one rational expression on each side of the equal sign. Type 2 was the type where one of the sides of the equal sign had more than one rational expression. Hopefully you can see that this is type 2 because our left side has more than one rational expression here. So this is type 2. The steps that we listed for type 2 were to find the LCD, convert all the fractions, to the LCD, and then cancel the denominators and solve what's left. So going through this, in order to find the LCD, first we have to make sure that every denominator we have is factored as far as it can go. X doesn't factor any further. X squared plus x does factor. It has a GCF of x, so that's x times x plus 1. X plus 1 does not factor any further. So step 1, find the LCD. Think about it yourself for a minute here, about what that LCD would be. All right, let's see if you were right. The LCD should be x times x plus 1. If you didn't get that right, let's think back to what the process for writing the LCD is. The first thing that we do is we look for what they have in common, any of those three fractions in the denominator. Well, they have an x in common here, so I write down x. Then they also have an x plus 1 in common, so I write that down. There is nothing left over. If there were anything left over, I would have to include it, but in this case there's not. So that's my LCD. Step 2, convert all fractions to fractions that have that particular LCD. And remember that there are lots of correct ways to do this, so if you do this differently and you get the same answer, that is perfectly fine as long as you show all of your work. All right, I converted all the fractions to the LCD. So I've got LCDs on the bottom, now I need to convert the tops. So remember, you ask yourself, what did I multiply the original denominator by to get my LCD? Hopefully you answered x plus 1, so that means I need to do the same thing to my numerator. 1 times x plus 1 is just x plus 1. Now over here I look and I ask myself, what did I have to multiply this original denominator by to get the LCD? Well, the answer is nothing here. These were the same. So it's like multiplying by 1, so it's just going to stay the same. Third fraction In order to go from this original to this LCD, I had to multiply by x, so I'm going to do the same on the top. Remember, when you're multiplying a binomial times x, you're distributing it, so that gives you x squared minus x. All right, I found the LCD. I converted all fractions to the LCD. Now I'm going to cancel the denominators and solve, because if we multiply the entire equation by the LCD, that's what it does. It cancels all the denominators. So I've got x plus 1 minus x minus 1. Remember, you have to distribute the negative. So minus x plus 1 equals x squared minus x. The solving part is going to depend on what type of equation you have. Generally, it's going to be linear or it's going to be quadratic. This one happens to be quadratic, which means after I combine like terms, here on the left side, the x and the minus x cancel, so this just gives me a 2. 2 equals x squared minus x. Since it's still quadratic, that means I need to get it equal to 0 and I need to solve. So I'm going to move this 2 over by subtracting it. So now I've got x squared minus x minus 2 equals 0. Quadratics, we have lots of ways to solve them. If we can, we like to factor them. So looking for what multiplies to negative 2 and adds to negative 1. There are factors that do that, negative 2 and positive 1. Remember to FOIL it back out. X squared minus 2 for first and lasts. Inside's negative 2x plus 1x does give me negative 1x. So this is correct. So that means that x equals 2. X equals negative 1. Remember that on rational equations you have to go back and you have to check your answers for extraneous solutions. Extraneous solutions will be anything that would make the denominator 0. So go back up and do a restriction on your original problem. Here, x can't be 0 because that would make this 0. X can't be negative 1 because that would make this 0. This is already covered with the 0. This is also a negative 1. So 0 and negative 1 are the no-nos. We did get one of those, so this guy needs to be crossed off because negative 1 would give me a 0 in the denominator, which means x equals 2 is my only viable solution. So that just kind of recaps a lot of what we did in the first part of lesson 31. Now we're going to take the solving of rational equations and we're going to apply it to some word problems. So if we look now, turn back to page 463, we have this problem right here. It says Jesse pitches for the baseball team and wants to improve his batting average before the county all-stars are selected. So he's wanting to be an all-star, knows that he needs to improve his batting average to get there. To date, he has 10 hits out of 40 times at bat. Number 1, batting average is the ratio of hits to at-bats. Write a ratio that represents Jesse's current batting average for this season, and then express the ratio in decimal form. Okay, so ratio of hits to at-bats. So hits for number 1, if I can get back, here we go. Hits to at-bats is the ratio that it told us to write. Jesse had 10 hits, he had 40 at-bats. So that's 1/4 if I reduce it. It says to express it as a decimal. Remember, you're allowed to use decimals in real life situations, but specifically here because they usually express batting average as a decimal with 3 decimal places. So we're going to write that 0.250. So usually they say that's batting 250. So this is Jesse's current batting average. Remember, Jesse wants to improve his batting average. Now, when we go back, they're going to tell us by how much. Jesse wants to improve his batting average to at least, meaning greater than or equal to, 0.320, so 320. If he gets a hit every time he bats, then his new batting average would be 10 plus x over 40 plus x, because he's batting however many at-bats is X, and it's saying if he gets a hit every time. So meaning that the number of at-bats is equal to the number of hits. So that's why it's X in both places. Number 2 wants us to take this and write an equation to determine how many consecutive hits he needs to bat 320. So we take this that they wrote us, which would represent the batting average, and we want that to be 320, or it could be bigger. We can't let it be smaller, so we want to solve this. So if we want to solve this, you can do this one of two ways. I would probably do this the way that we did in lesson 31. If you look at this as a rational equation, I would kind of write it as a ratio and then cross multiply here. So
math is great.
That's Mr. Hewland. That's him saying hi. So I can cross multiply here. 1 times 10 plus x is 10 plus x. Then when I go to multiply 40 plus x times 0.320, I have to distribute there. So when I do that, I multiply the 0.320 times the 40 and the 0.320 times the x. So 0.320 times 40 is 12.8. So 12.8, and then plus 0.320 times x is just 0.32x. So now I have a linear equation that I want to solve. So because it's linear, generally we're going to get x's to one side, numbers to the other. So here I am going to subtract 0.32x over to this side and subtract 10. So that way I've got numbers over here on the right, which gives me 2.8. And then I've got variables over on the left side. 1 minus 0.32 is 0.68. So I've got 0.68x equals 2.8. So last step is to divide. So divide by 0.68. 2.8 divided by 0.68 gives me x is approximately equal to 4.1176, so on and so forth. Now, this is the solution that we got for x. Keep in mind what we are trying to answer here. If we turn the page, these are the things that we already did. Oops, where's number 3? Somehow I skipped it. There it is. Solve the equation you wrote in item 2 to find the number of consecutive hits. That's what we're solving for, the number of consecutive hits. Now, Jesse can't hit the ball 4.1176 times. He can either hit the ball 4 times or he can hit it 5 times. Remember also that we said we wanted the batting average to be at least. So although if we were just rounding without regard for the question, we would make this a 4. Because this is a real life situation and what it represents, we have to round that up to 5 hits, because if he only gets 4 hits, 10 plus 4 over 40 plus 4 will be short of this batting average goal. So he needs to hit 5 in order to make that work. All right. So that is one example of a rational equation where we've got a real life situation. So this was also number 3, the solving was. Now we are going to move over, because again we did the rest of the other types in the first part of the lesson. We're going to move over to page 465 to number 8. It says Jesse's coach requires, and it'd probably be better if I pulled it up here. Jesse's coach requires the team to help prepare the baseball diamond at school. Jesse and Cody working together can clean up the infield in 2 hours. If Jesse worked alone, it would take him 5 hours. To figure out how long it would take Cody to prepare the infield by himself, you must consider the portion of the job that can be completed in 1 hour. So what we're doing here is called a work problem, and when we unpacked the embedded assessment, I think you saw that there was a big work problem. in there. So very important that you know how to set up and solve these types of problems. What we're going to do here is walk you through it step by step to make sure you understand what we're doing. Once we've done it once, these work problems follow a pattern and hopefully it will be easier. So first kind of step along the way that they're having us answer, if it takes Jesse 5 hours to complete the whole job by himself, what fraction could he complete in 5 hours? So he can do the whole thing in 5 hours. Oops, I read that wrong. What fraction could he complete in 1 hour? So 5 hours gets you the whole thing. What fraction could you get in 1 hour? And again, we're assuming that he works at an even pace. So what do you think? How much, what fraction could Jesse complete in 1 hour if it takes him 5 hours to do the whole job? Hopefully you came up with 1/5, because if it takes him 5 hours to do the whole thing, in 1 hour he's taken 1 out of the 5 that he would need. So 1/5 of the job is what Jesse can complete in an hour. Number 9, if it takes Cody T hours to complete the job, because again, that's what we don't know. How long will it take Cody? If it takes Cody T hours to complete the job, what fraction could he complete in 1 hour, assuming he works at an even pace? So same question as number 8, except we don't know how many hours it takes him to do the whole job. So that means that number 9, the answer is 1/T. Because if it takes him T hours for the whole thing, 1/T is what he can do in 1 hour. Number 10, Jesse and Cody working together can clean up the infield in 2 hours. What fraction of the job can they complete in 1 hour if they work together? So again, very similar to 8 and 9. Together it takes them 2 hours to do the whole thing, which means, hopefully you've already answered this yourself, that they complete 1/2 of it in 1 hour. So it would take them 2 hours to do the whole thing. If they only have 1 hour, they're going to get half of it done. So, number 11, model with mathematics. Now write an equation using the verbal model below. Jesse's work in 1 hour plus Cody's work in 1 hour equals together work in 1 hour. So, Jesse's work in 1 hour was 1/5 plus Cody's work in 1 hour, which was 1/T, equals together work in 1 hour, which was 1/2. Great. Number 12, solve the equation you wrote in item 11 to determine how long it would take Cody to complete the job if he worked alone, because that's what T represents, how long it would take Cody to complete the job by himself. So, go ahead, solve this equation. Notice it's a very easy rational equation to solve. So, pause the recording for a minute. I'll give you some time to try to solve that. All right, again, if you didn't pause it to solve, please do. That's the only way you know where your thinking is compared to where it needs to be. All right, so over here, I'm going to show you the way probably most of you did it, and then I'm going to show you the easier way. Probably most of you looked at this as a rational equation and said, okay, I need the common denominator, which the factors are 5, 2, and t, so that makes my LCD 10t. And so, if you use an LCD of 10t, just like we did with our other rational equations, here I would have had to multiply by 2t, here I would have had to multiply by 10, and here I would have had to multiply by 5t. So that gives me 2t here, 10 here, 5t here. So 2t plus 10 equals 5t. Subtract 3t from both sides. Oops, why am I subtracting 3? Because 3 is the answer. Oh my gosh, getting ahead of myself. Subtracting 2t from both sides, which gives you 3t, and then dividing to find that t is equal to 10/3. So it would take 10/3 hours for Cody to complete the job, which is 3 1/3 hours. Now, that's Probably what many of you did because you're used to the rational equations. Now, I want you to notice that actually it would be a lot easier if we just took this original. If I'm trying to get t alone, why not just subtract 1/5? So now 1 over t equals 1/2 minus 1/5, which, yes, you would need a common denominator for that. That's tenths. But you've got 5/10 minus 2/10, which is 3/10. And then you could cross multiply, and you get the exact same thing. So less work to do it this way. We're not always lucky enough to be able to do it that way, but just wanted to point that out for you. So that's the answer to number 12. 3 1/3 hours is how long it would take Cody to complete it by himself. So then number 13, because this was number 12, was our actual solving. So number 13, use your answer to item 12 to determine what fraction of the job Cody could complete in 1 hour. Well, it's always 1 divided by how long it takes him to do the whole thing. So 1 divided by 10/3 is just the reciprocal of 10/3, which is 3/10. So 3/10 of the job is how much Cody could complete in 1 hour. All right. Last little thing we're going to do here, number 14. We're adding in a new person. Garrett. Sorry about the printer noise back there. It says Garrett has cleaned up the infield on his own before, and it took him 4 hours. How long will it take all 3 boys working together to prepare the infield for a game? Show your work. So these work problems we're going to set up the same way every time. You're going to do 1 over how long it takes each person to complete the job individually. So we know that it takes our first friend, Jesse, 5 hours. So 1 over 5 represents Jesse. Now, Cody, we just solved for. So we know that it takes Cody 3 1/3 hours, or 10/3. So 1 over 10/3 is what we just did here. So takes Cody 3/10 of an hour to do it by himself. Now we've got a third friend, Garrett. Says it takes Garrett 4 hours to do it by himself. So that means 1 over 4 would represent how much Garrett could get done in an hour by himself. So all 3 friends working together is what we want to know. Again, this represents how much they can do in 1 hour. Don't set this equal to t. It's equal to 1 over t, because this is going to represent how much, if you just set it equal to t, what you get represents how much they could get done in 1 hour, because that's what each of these is. So please, please, please make sure that we're always putting those in the denominator. So this is the equation you want to solve for 14. This is also a pretty easy equation over here. You could find common denominators between all of them if you wanted, making a common denominator of 20t. However, I'm going to propose that we make it a little easier on ourselves and just add these fractions together and then cross multiply. So if you want a common denominator of 20, that would mean I multiplied this by 4, so this by 4 times 2 times 2 times 5 times 5. So 4 plus 6 plus 5. So that gives us 15 over 20 equals 1 over t. 15 over 20 reduces. They're both divisible by 5. So reduce that to 3/4. And then I can very simply solve by cross multiplying here. So 3 times t is 3t. 1 times 4 is 4. Divide by 3. And t equals 4/3. Again, we're solving for how long it would take all of them working together. So 4/3 hours, or 1 1/3 hours, would probably make a little bit more sense there. All right, homework is the 30-1 practice. Again, the first several are like what we went through in the first part of the lesson that we reviewed here in number 6. Make sure that you look to see which type it is before you try to solve. And then the last 2 questions are work problems, again set up similar to what we just went through. And that is all. Have a good day.